All right, Aubrey and whoever else is watching this, we are on 12:5. Here's a homework assignment for this section. There you go. Let's go up to the top. This is strictly multiplying. Okay, multiplication rule. Yesterday we talked about on your little cheat sheet how you know when you're going to multiply versus add. Okay, so the example, one of the examples that I gave you was what's the probability of drawing a 7 and then a king, right, out of a deck of cards. So one thing that tells you need to multiply is the word and, right? Okay, and 2 or more events. So here I am actually drawing 2 cards. Okay, I'm doing 2 or more events. I could draw 3 cards. I would just multiply those 3 together, right? Okay, so the words and 2 or more events tell me that I need to multiply those together. So 7 has a 4 out of 52 chance. King has a 4 out of 52 chance. I would reduce and multiply and do all the things, right? Okay, which reduces to 1 over 169. Okay, that's how you work that problem. Got it? But the thing that we have to be aware of when we're multiplying is whether they are independent versus dependent. And a lot of times you see dependent events. Where are we at? I'll just write dependent. If the events are dependent, you will a lot of times see these words. What? Dependent, you will a lot of times see the words without replacement. Okay? Dependent without replaced, which means instead of doing out of 52 cards, you're doing it out of 51 cards, right? Okay? So that's when you'll have a dependent event. Now, independent means you are replacing or you have 2 completely separate things going on. So maybe I am tossing a coin. A coin is tossed, and then I'm spinning a spinner, right? Those are independent events. I'm still going to multiply, but those are independent events. They don't have to say with, replace, without replace, because they're 2 completely separate events, right? That I'm just doing consecutively. Got it? Okay. So they say the sample space for tossing a coin and then spinning this spinner is I could get a head and spin a 1, heads 2, heads 3, or I could do tails 1, tails 2, tails 3. There are 6 different outcomes that I could get, right? Got it? The first outcome, heads or tails, has 2. The second outcome is a spinner that has 3 sections, and 2 times 3 is 6 total in my sample space. Got it? When you're listing out your sample space, it looks like this. All right, we're going to be doing probability here in a second. Let's do this. They say the probability of heads and then getting a 2. The probability of getting a heads is 1/2. The probability of spinning a 2 is 1/3. I multiply those together and I get 1/6. Got it? You're multiplying. You're doing 2 events, right? Okay, let's go to example 1. Anna is a member of a gaming website that randomly pairs users together to solve puzzles. What?
If I can't sit there, neither can Lauren.
My chair's not. Oh my gosh. I know you all like me so much.
What do you want?
We'll give them a chance until they prove otherwise that they shouldn't. Okay. All right. She's a member of a website that we're solving puzzles. Of the 50 other players currently online, Anna is friends with 10 of them. Suppose Anna is paired with a player for a game. Not liking the outcome, she disconnects and is paired again. What is the probability that she is not paired with a friend in either match? So she's doing match number 1, match number 2, okay? In match number 1, if she's not paired with a friend, 10 of them are friends out of 50, right? So what's the chances of her not being paired with a friend over here? 40 out of 50. Now, she disconnects because she's not paired with a friend, right? What's the chances the second time around that she's not paired with a friend?
40 out of 50.
Now, here's my question. You're saying 40 out of 50. Could she, let's say she's paired with, I don't know, Dylan, because nobody likes him. Okay, let's say she's paired with Dylan, and then she disconnects because she wants to get paired with somebody different. Could she be paired with Dylan again?
Yeah.
Yes, so the bottom number is still 50, true? If they're saying you wouldn't be able to be paired with Dylan the second time around, you'd be paired with somebody different, then it would be 49. Do you see the difference? That is without replacing, right? Okay, but Dylan gets replaced back into the pot, and she could, in fact, draw Dylan again, right? So I have that going on. I'm going to multiply. Before I multiply, I would reduce. I would divide by 10, right? And I have 4/5 times 4/5, which is 16 25ths, or 64%. Can you do that in your head?
No, not at all.
You can. 25 is my bottom number. Percentage is out of 100. So if I multiply the bottom number by 4, I get 100. If I multiply the top number by 4, it's 64%, right? That's very easy to do when you have 25s or 20s or 10s or whatever, right? You can do those percentages. Very nice, okay? B says, what assumption do you have to make in order to solve this problem? We already talked about this, but what is it?
You can
That
pair with
he's-
Can pair with same person second time, right? Shh. You can be paired with the same person the second time. So they're both out of 50. Got it? Okay, good? All right, moving on. Next one. Probability of dependent events. This is without replace. Put that down. Without replace. Dependent events. All right. Let's go to example 2. Determine whether the events are independent or dependent. You can put I or D next to A, B, C. I'll do the first one with you. You do B and C, independent, dependent. One spinner is spun twice. Is that independent or is that dependent? Does the spinner now have less sections on it the second time I spin? No, they're independent, right? It's not like I'm subtracting one from the bottom number. All right, you do this. Don't shout it out. B and C, you figure out whether they're independent or dependent. Put I or D next to them. Go. You're not finding any probabilities. You're just putting I or D next to B and C. Go. I'll give you 15 seconds. Okay, B. In a raffle, one ticket is drawn for first prize and then another ticket is drawn for a second prize. This one's hard. Independent or dependent?
Dependent.
Because you take out the ticket that was drawn.
Yeah. And you don't put it back.
Now, they don't say whether they put it back or don't put it back. So which one do we assume?
They put it back.
Is removed. It cannot be chosen again. That means
Well, they don't say it down. They say it down below.
It is removed and cannot be chosen.
Still.
Where?
But it's one. It's
But it doesn't say that. It doesn't say that. If we didn't, we wouldn't know unless we read this bottom part right here.
But it's
Right?
one for first place and one for second.
They only say part B. Hold on. Because you'll have problems like this on your homework assignment. If we're only given the information in part B, do we assume that they put it back or assume that they don't put it back?
It's one for first place and second.
Well, it's the same.
They're
It's the same.
different.
You can't
Two
have
different
the
people
same
gonna do the
So
same
you
prize.
can't draw the same one for first. Because you could draw the same one for both places and it would work.
Right. So,
Can't win first.
for a couple different reasons. They don't say that you put it back. We're going to assume that you don't. Okay? That's always the assumption that we make. Unless they say you put it back, we're going to assume that you don't. And also, Ella and Brady both said you can't win first and second prize at the same time. Or maybe you can. I don't know. Some places you might let you. What?
But not with the same ticket.
Right, but
Right?
you can win two
I
different
don't know.
tickets.
Yeah.
I don't know.
No,
So,
it's
yeah, you can't use the same ticket to win, right?
It'll be
Yeah.
a different ticket.
Yeah. So,
You're in the pot,
So-
you put the ticket within it.
independent, dependent.
Dependent.
Dependent. All right, move on. A random number generates two numbers.
I agree.
Independent. They do not delete the number when you hit the random number generator, you could get 7 6s in a row, right? Or 7, whatever. You could get a bunch of the same number in a row because it's independent. They will put that same number back in the pot. Got it? Okay, let's go down. Example 3. Next. Go to the next page. Example 3. Flip over. Example 3. All right, the pizza that Jose and Tessa are eating has 10 slices and is half cheese, half mushroom. I'm going to draw a picture. Whoop. Yeah, right. Correct. 1, 2, 3, 4, 5.
Those are very even.
Those are they even?
Absolutely.
I don't know. Whatever. I don't know. Whatever. Half cheese, half mushroom. There's my picture. Half cheese, half mushroom.
Why'd you draw them all in the center. We just
I don't know. I tried. I was trying to keep them even. Anyway, just worry about yourself. All right. All right. Tessa spins the pizza around and randomly selects a slice of mushroom pizza. Hold on. She randomly selects a slice of mushroom pizza, so this one's now gone. If Jose spins the pizza and selects a slice after that, what is the probability that both he and Tessa select a slice of mushroom pizza?
4/10.
Why 4/10?
Because
So then he spins the lazy
Well,
Susan.
Why not
pizza.
2/5?
because there was 5 mushrooms, but now there's only 4 mushrooms.
But no, it doesn't say it's on the lazy Susan. So it's-
And randomly selects a slice of mushroom pizza.
Yeah.
I don't like the way that this is worded because it sounds like she's already selected the mushroom pizza. But we want to know the chances of mushroom and then mushroom again.
Okay, why don't you just
Whatever.
reach over?
So
Whatever. 5 out of 10 times. If she's already eaten it, 4 out of 9. Okay, let's reduce. Hold on, let's reduce. 5 over 10 is 1/2.
I'm removing.
What else can I reduce?
Nothing.
Yes.
Absolutely nothing.
A 2 and the 4.
The 2 and the 4 becomes 1 and 2. Okay? So 1 times 2 is 2. 9 times 1 is 9. 2 ninths. Shh. You need to pay attention.
That's it.
You need to pay attention.
22%.
2 ninths. 22%.
Yay, we're
Okay? Good? Oh my gosh, that's it.
Yep.
What?
Then 2 max.
Yep.
Crazy. All right, there you go. Homework already.
That's done.
You need to use your time in class. If you do not use your time in class to work on this, I will make this due at the end of the period. How about that? Okay, bazinga. Use your time in class to finish this. Otherwise, I will make it due.
Call me your phone filling in for the second time.
That would be great. Okay, goodbye, people watching this video.